Hello friends, good morning. Today we'll start practical work in geography. Textbook for class 12. Okay. So here it is the syllabus of EMRS. As per the EMRS syllabus, you can see these topics are there. First thing is fundamentals of maps and second is heading topographic and weather maps. इसके अंदर आप पढ़ोगे तो देखो अंडर दिस टू हेडिंग्स यू गॉट जियोस्पेशियल डेटा, concept of geographical data matrix, point line area data, maps types, scale types, construction of simple linear scale, measuring distance, finding direction and use of symbols, map projection, latitude, longitude and time, typology, construction and properties of projection, conical with one standard parallel and marketer projection. Under the topographic and weather maps, we get study of topographic maps 1:50,000 or 1:25,000. Survey of India maps, contour cross section and identification of landforms, slopes, hills, valleys, waterfall, cliffs, distribution of settlements, satellite imageries, stages in remote sensing data acquisition, platform and sensors and data products, photographic and digital. ठीक है. So we will cover all these topics and we will at least try to cover the NCERT books, that is class 11 and class 12 practical books, and I and hope all the topics will be covered if we complete these two books. So I am starting a video series on these two books and we will start with the class 11th book. So first chapter is introduction to maps. First chapter is introduction to maps. So let's start. You may be familiar with maps that you have seen in most of your books of social sciences representing the earth or any of its parts. You may also know that the shape of the earth is geoid, that is three-dimensional, and a globe can best represent it. Okay, so remember this line: a globe best represent our earth. A map, on the other hand, is a simplified depiction of whole or part of the earth on a piece of paper. A map is a simplified depiction of whole or part of the earth on a piece of paper. In other words, it is a two-dimensional form of the three-dimensional earth. So globe is three-dimensional, map is two-dimensional. Hence a map can be drawn using a system of map projections. As it is impossible to represent all features of the earth's surface in their true size and form, a map is drawn at a reduced scale. A map is drawn at a reduced scale. Imagine your school campus. If a plan or map of your school is to be drawn in its actual size, it will be as large as the campus itself. Hence, maps are drawn at a scale and projection so that each point on the paper corresponds to the actual ground position. Besides, the representation of different features is also simplified using symbols, colors and shades. A map is therefore defined as a selective, symbolized and generalized representation of whole or a part of the earth's surface on a plane surface at a reduced scale. It may also be understood that a simple network of lines and polygons without a scale shall not be called a map. So if there is no scale, it shall not be called as map. It is only referred to as the sketch. So a map without scale is a sketch. In the present chapter, we will study the essential requirements of maps, their types and their usage. But before that, we will consider this glossary part. So here it is: cadastral map, a large scale map. Cadastral map is a large scale map drawn at a scale of 1:500 to 1:4000. 1:500 to 1:4000 is called as cadastral map. To show property boundaries, designing each parcel of land with a number. Then cardinal points we have not. We have four directions mainly: north, south, east and west. So these are called cardinal points. Cartography, art, science and technology of making maps, charts, plans and other models of geographical expression as well as their study and use. Generalization map, a simplified representation of the features on the map appropriate to its scale or purpose. without affecting their visual form. Geoid and oblate spheroid whose shape resembles the actual shape of the earth. Map is selective, symbolized and generalized representation of the whole or part of the earth at a reduced scale. Map series, a group of maps produced at same scale. Okay, map series, a group of map produced at a same scale. Style and specifications for a country or a region. Same scale, style and specifications for a country or a region. Projection map, the system of the transformation of the spherical surface onto a plane surface, that is projection of map. What is scale? The ratio between the distance of 2 points on the map, plan or photograph, and the actual distance between the same 2 points on the graph. The ratio between the map distance and the actual distance is called scale. Sketch map, a simplified map drawn freehand which fails to preserve the true scale or which fails to preserve the true scale or orientation, that is a sketch map. Now, essentials of map making. In view of the variety of maps, we may find it difficult to summarize what they all have in common. Cartography, being an art and science of map making, does include a series of processes that are common to all the maps. These processes that may also be referred to as essentials of maps are scale, map projection, map generalization, map design, map construction and production. Let us look about the scale. Okay, scale, we know that all maps are reductions. The first decision that a map maker has to take is about the scale of the map. The choice of a scale is of utmost importance. The scale of a map sets limits of information, contents and the degree of reality with which it can be delineated on the map. For example, comparison between maps having different scales and the improvements made thereupon with the change in scale. Figure 1.3. I think this is the basic. You don't need. Here you can see that scale of the map and the details of the information is available. So effect scale or mapped information you can see here, right? So yeah, okay. Next, projection. We also know that maps are a simplified representation of the three-dimensional surface of the earth on a plain sheet of paper. The transformation of all side curved geodal surface into plane surface is another important aspect of the cartographic process. We should know that such a radical transformation introduces some unavoidable changes in directions, distances, areas and shapes from the way they appear on a geoid. A system of transformation of the spherical surface to the plane surface is called a map projection. Hence, the choice, utilization and construction of projections is of prime importance in map making. Then generalization. Every map is drawn with a definite objective. For example, a general purpose map is drawn to show information of a general nature such as relief, drainage, vegetation, settlements, means of transportation, etc. Similarly, a special purpose map exhibits information pertaining to one or more selected themes like population density, soil types or location of industries. It is therefore necessary to carefully plan the map contents, while the purpose of the map must be kept in forefront. As maps are drawn at a reduced scale to serve a definite purpose, the third task of a cartographer is to generalize the map contents. In doing so, a cartographer must select the information data relevant to the selected theme and simplify it as per the needs. Next is map design. The fourth important task of a cartographer is the map design. It involves the planning of the of graphic characteristics of maps, including the selection of appropriate symbols, their size and form, style of lettering, specifying the width of line, selection of colors and shades, arrangement of various elements of map, design within a map, and design for map legend. The map design is therefore a complex aspect of map making and requires through understanding of the principles that govern the effectiveness of graphic communication. Okay, तो यहाँ पर आता है आपका art map design. Here the art map making is an art. Map construction and production. The drawing of maps and their reproduction is the fifth major task in the cartographic process. In earlier times, much of the map construction and reproduction work used to be carried out manually. Maps are drawn with pen and ink and printed mechanically. However, the map construction and reproduction has been revolutionized with the addition of computer-assisted mapping and photo printing techniques in the recent past. History of map making. The history of map making is as old as history of mankind itself. The oldest map was found in Mesopotamia, drawn on a clay tablet that belongs to 2500 BC. So the oldest map is a clay tablet. Okay, the oldest map was found in Mesopotamia, drawn on a clay tablet that belongs to 2500 BC. So the oldest map belongs to 2500 BC. This is important information you should remember. The oldest map was found in Mesopotamia, drawn on a clay tablet that belongs to 2500 BC. Then figure 1.4 shows Ptolemy's map of the world. Greek and the Arab geographers laid the foundation of modern cartography. Greek and Arab geographers laid the foundation of modern cartography. Who laid the foundation of modern cartography? Greek and Arab geographers. The measurements of the circumference of the earth and the use of the system of geographical coordinates in map making are some of the significant contributions of the Greeks and Arabs. The art and science of map. So this is the map of Ptolemy. This is the map of Ptolemy. How he depicted the world. The art and science of map making was revitalized in early modern period, with extensive efforts made to minimize the effects of the transformation of the geoid onto a plane surface. The maps were drawn on different projections to obtain true directions, correct distances, and to measure area accurately. The aerial photography supplemented the ground method of survey, and the uses of aerial photographs stimulated map making in the 19th and 20th centuries. The foundation of map making in India was laid during the Vedic period, when the expression, so in India, the foundation of map making is found in the Vedic period, when the expressions of astronomical truths and cosmological revelations were made. The expressions were crystallized into siddhantas or laws in classical treatises of Aryabhatta. So Barahmihir and Bhaskara and others. So Aryabhatta, Barahmihir and Bhaskara, they are the ancient cartographers for India, or in India, in ancient India. Ancient Indian scholars divided the known world into 7 dipas. The ancient India was divided by them into 7 dipas. Mahabharata conceived a round world surrounded by water. Okay. So 7 dipas of the world as conceived in ancient India. You can see this map as well. This is Kraukadeep, Jambudeep, Puskaradeep, Sakodeep, Bharatkhand, Kushadeep, Plaskadeep, and Shalmali Deep. Okay, Shalmali Deepa. Abhi Milky Ocean, then Aryabhat Barsho, बापरे हिरण्यक बरसो, भद्रवर्षो. ओके, इसको हम बाद में कंसिडर करेंगे, अभी समझ में नहीं आ रही इसको. चलो. Then Todermal pioneered land surveying and map making as an integral part of the revenue collection procedure. Then come this Todermal kingdom. Besides Sher Shah Suri's revenue maps further enriched the mapping techniques during the medieval period. So Sher Shah Suri also did something during medieval period. The intensive topographical surveys for the preparation of up-to-date maps of the entire country were taken up with the setting up of the Sarva Pinda in 1767. So Sarva Pinda was established in 1767. This is very important information. Sarva Pinda was established in 1767, which culminated with the map of Hindustan in 1785, and first map was produced in 1785. Today the Sarva Pinda produces maps at different scales for the entire country. Sarva Pinda was established in 1767. First map was produced in 1785, and today it produces all the maps Okay, then types of maps based on scale. On the basis of scale, maps may be classified into large scale and small scale maps. Large scale maps are drawn to show small areas at a relatively a large scale. For example, the topographical maps drawn at a scale 1 is to 2 lakh 50,000, 1 is to 50,000 and 1 is to 25,000, and the village maps, the zonal maps of the cities, and house map plans prepared on a scale of 1 is to 4,000, 1 is to 2,000 and 1 is to 500 are large scale maps, right? So when the number is big, I mean this number is big, that is a small scale map. When this number is small, that is a large scale map. It is quite reverse the situation. On the other hand, small scale maps are drawn to show large areas, and small scale maps are shown to show a large areas. Itni see the area map size is like this, and another map is like this, but here we are showing the entire India, and here we are showing only one district of West Bengal. So this is just small scale map and this is a large scale map. Then for example, atlas map, wall maps, these are the small scale maps. Okay, cadastral maps are example of large scale maps. Then large scale maps are further divided into following types, that is cadastral maps and topographical maps. So cadastral maps and topographical maps are example of large scale maps. Cadastral maps are the cadastral maps. Now the term cadastral is derived from the French word cadastre, meaning register of territorial property. Cadastre. Cadastral is derived from the French word cadastre, meaning register of the territorial property. These maps are drawn to show the ownership of landed property by demarcating field boundaries of agricultural land and the plan of individual houses in urban areas. The cadastral maps are prepared by the government agencies to realize revenue and taxes, along with keeping a record of ownership. These maps are drawn on a very large scale, such as the cadastral maps of villages at 1 is to 4,000 scale and the city plans at scale of 1 is to 2,000 and larger. This is the cadastral maps, right? And the main purpose is ownership of land property. Okay, to show the ownership of land property. Topographical maps, these maps are also prepared on a fairly large scale. The topographical maps are based on precise surveys and are prepared in the form of series of maps made by the national mapping agencies of almost all countries of the world. For example, the Survey of India undertakes the topographical mapping of the entire country at 1 is to 2,50,000, 1 is to 50,000 and 1 is to 25,000 scale. These maps follow uniform colors and symbols to show topographic details such as relief, drainage, agricultural land, forest, settlements, means of communication, location of school, post office and other services and facilities. Small scale maps is also two following types, that is wall maps and atlas maps. So wall maps, these maps are generally drawn on a large size paper or on plastic base for use in classroom or lecture halls. The scale of wall maps is generally smaller than the scale of topographical maps but larger than the atlas maps, right? The scale of wall maps is generally smaller than the scale of topographical maps but larger than the atlas maps. Then atlas maps. So atlas maps are very small scale maps. These maps represent fairly large areas and represent highly generalized picture of the physical or cultural features. Even so, an atlas map serves as a graphic encyclopedia of the geographical information about the world, continents, countries or regions. When consulted properly, these maps provide a wealth of generalized information regarding location, relief, drainage, climate, vegetation, distribution of cities and towns, population, location of industries, transport network system, tourism and heritage edge sites. Okay, so atlas maps are highly generalized maps and they are very small scale map. So if you get a question to arrange the maps as per the scale, so first will come the atlas map. If it is arranged from small to large scale, so first will come atlas map, then आपका next will come the wall map, okay, and then the others like topographical maps and then cadastral maps. This is the sequence. And types of maps based on function. The maps may also be classified on the basis of their functions. For example, a political map serves the function of providing administrative divisions of a continent or a country, and a soil map shows the distribution of different types of soils. Broadly, maps based on their functions may be classified into physical maps and cultural maps. Physical maps show natural features such as relief, geology, soil drainage, elements of weather, climate and vegetation, etc. Relief maps show general topography of an area like mountains and valleys, plains, plateaus and drainage. Okay, and geological maps, these maps are drawn to show geological structure, rock types, etc. Climate maps, these maps depict climatic regions of an area. Besides, maps are also drawn to show the distribution of temperature. So here it is distribution of rocks and minerals in Nagpur district. So this is geological maps and climatic conditions. So this is climatic map. Okay, soils and Nagpur. So this is physical map. Rainfall, cloudiness, relative humidity, direction and velocity of winds and other elements of weather maps. This is soil map. So maps are also drawn to show the distribution of different types of soils and their properties. So that is a different types of map. That is a soil map, right? Then cultural maps. So cultural maps show man-made features. These include a variety of, these are the physical maps. So physical maps are of four types. There is relief maps, geological maps, climate maps, climatic maps and soil maps. Okay, so relief, geological, climatic and soil maps. Okay, and next is cultural maps. So cultural maps show man-made features. These include a variety of maps including showing population distribution and growth, sex and age, social and religious composition, literacy, levels of educational attainment, occupational structure, location of settlements, facilities and services, transportation lines and production, distribution and flow of different commodities. Political maps, these maps show the administrative division. So these are the types of cultural maps. First one is political map. These maps show the administrative divisions of an area such as country, state or district. These maps facilitate the administrative machinery in planning and management of the concerned administrative unit. Population maps, the population maps are drawn to show the distribution, density and growth of population, age and sex composition, right? And then next, distribution of religious, linguistic and social groups, occupational structure of the population, etc. Population maps serve the most significant role in the planning and development of an area. Population maps serves the most significant role in planning and development of the area. Now economic maps. Economic maps depict production and distribution of different types of crops and minerals, location of industries and markets, routes for trade and flow of commodities. Okay, and the land use and cropping patterns and the location of industries in Nagpur district. These are the example. Then other transportation maps. So transportation maps, these maps show roads, railway lines and the location of railway station and airports. This is the transportation maps. Then industries, so in location of industries, this is the example of economic map. Industries will come under economic maps. Okay, so these are basically theme based maps. So I don't know why it is not mentioned here, theme based map. That is a type of map as well. Then usage of maps. So geographers, planners and other resource scientists use maps. In doing so, they make various types of measurements to determine distances, direction and area. Measurement of distance. The linear features shown on the maps fall into two broad categories: straight lines and erratic or zigzag lines. The measurement of straight line features like roads, railway lines and canals is simple. It can be taken directly with a pair of dividers or a scale placed on the map surface. However, distance are required more often along erratic paths and the coastlines, rivers and streams. The distance along such features can be measured by placing a thread at a starting point and carrying it along the line up to the end point. The thread is then stretched and measured to determine the distance. It can also be measured by using a simple instrument called rotameter. So remember this name, rotameter, used to measure the distance on map. The wheel of the rotameter is moved along the route to measure the distance. Then measurement of direction. So direction is defined as an imaginary straight line on the map showing the angular position to a common base direction. The line pointing to the north is zero direction or the base direction line. Okay, so zero direction or base direction line is also known as the north direction. North is also known as zero direction or the base direction line. So you can see this diagram, how many direction are there. Okay, then A map always shows the north direction, so all other directions are determined into this relation. So the north direction enables the map user to locate different features with respect to each other. The four commonly known directions are north, south, east and west. These are also called the cardinal points. Okay, we read at the beginning cardinal points. In between the cardinal points one may have several intermediate directions. So in between these four directions, whatever directions we can identify, that will be called as the intermediate directions. Then measurement of area. The measurement of area of features like that of administrative and geographic units is also carried out over the surface of the map by map users. There are different methods in which areas can be determined. One of the simplest but not very accurate method to determine the area by means of regular pattern of squares. In this method, the area to be measured is covered by squares by placing a sheet of graph paper beneath the map of an illuminated tracing table or by tracing the area onto the square sheet. Okay, so this is square. We usually use the area by square, kilometer, square meter, like that. So how do we measure that? So here it is given ki by means of regular pattern of squares. In this method, the area to be measured is covered by squares by placing a sheet of graph paper beneath the map on an illuminated, that means like a tracing paper. Okay, so it is visible from the below. The graph paper is visible from the beneath the map. Okay, so like that. Or light tracing, as we use during the practical work. The total number of whole squares are summed up together with partial squares. The area is then determined by a simple equation. So area sum of whole squares plus sum of partial squares divided by 2 into map scale, right? So this is the formula, sum of whole squares plus sum of partial squares divided by 2 into map scale. The area can also be calculated by using a fixed area polar planimeter. The area can also be calculated using a fixed area polar planimeter. The planimeter is used for the area measurement. Then measurement of using area polar planimeter. So you can see this instrument. The area calculations is also carried out using polar planimeter. In this instrument, a measure is made of the movement of a rod whose locus is constrained by having one end fixed to a radial arc. The area to be measured is traced along its perimeter in a clockwise direction with an index mark starting from one convenient point to which the index of the tracing arm must exactly return. Reading on the dial before and after the tracing of area's perimeter will give a value in instrumental units. These readings are multiplied by the same constant for the particular instrument to convert into areas in square inches or centimeters. You may explore more on bhuban.nrsc.gov in. You can visit this website for more to understand this. Okay, so remember this name. A polar planimeter is used to measure the area, and one instrument another we got the rotameter that is used to measure the distance. And the simple method to calculate the area is to placing graph paper beneath the map and then counting the squares and using that formula, sum of whole squares plus sum of partial squares divided by 2 into map scale, right? So here it ends the chapter 1. Now let us see the exercises also. Which one of the following is essential for the network of lines and polygons to be called a map? Which one of the following is essential for the network of lines and polygons to be called a map? Definitely map scale is the most essential. A map bearing a scale of 1:4000 and larger is called cadastral map. Which one of the following is not an essential element of maps? Map projection, map generalization, map design, history of maps. So history of maps is not an essential element of map. Answer the following questions in about 30 words. What is map generalization? Why is map design is important? What are different types of small scale maps? List out 2 major types of large scale maps. How is a map different from a sketch? Write an explanatory account of types of maps. So you can try answering these questions, and in our next video we will discuss about the map scale, that is the chapter 2. Okay, so I am pausing this video here, and definitely it will be a we will start the chapter 2 from the next video. Thank you friends, thanks for watching.